So in today's video, I'm going to be taking up the Physics 1A03 final exam for June of 2025. This is also the practice exam that was provided for us for the fall 2025 cohort. And I'm only going to be taking up the content that is on the second half of the course material, so from questions 16 to 30, because there are 30 questions here, and that will take a lot of time. I have made a community post posting the worked out solutions for the first half of this exam. And I also have two other videos on like physics midterms. So I'm only going to start by doing question 16 in this video. So a safe is suspended at a height of 2.2 meters above the top end of an unstretched spring. The rope holding the safe breaks and it falls and it compresses the string. It momentarily stops when the spring is compressed at a total distance of 1.26 meters. So let's just say 1.26 is around this much. So this is a work energy problem. So at the very top, I only have gravitational potential. So UG equals mgh. The mass is what we're trying to find. So this is 9.8. Height is going to be 220 plus 1.26 because I'm treating the spring when it's compressed as 0. So this is going to be 33.9 times mass. And then at the bottom, when it falls onto the spring, I have spring force, which is half kx squared. So we know k is 22383, and it's compressed by 1.26. So if you calculate this, we'll get 17767.63. So this is also equal to the total amount of energy in the system. So I can say that 33.9 times mass equals this energy because energy is conserved. And now you just simply solve for m, and this will give you 524 kilograms. Next, a gardener pushes a lawnmower whose handle is tilted up at 23.7 degrees above the horizon. A constant force of friction acts on the lawnmower. So it's this way. And how much power does the gardener have to supply to push the lawnmower at a constant speed for 117.2 seconds? So a very key point in this question is constant speed. So because the lawnmower is pushing at an angle, we have some like horizontal component and also vertical component of the applied force. So horizontal component is going to be this way, and then vertical component is going to be down. Because it says constant speed, we know that there's no net force because acceleration is 0. So then the force of friction and the force applied in the x direction are equal to each other. So that means the amount of force that the gardener is applying to push the lawnmower is going to be equal to the friction, which is 38.2. Okay, so work equals force times the distance. So the force is 38.2, the distance is 89.9, and this is 3434.18. Next, power is simply work over time. So you just do this, divide by 117.2 seconds. And this should be 29.3 watts of power. Question 18. The work expanded to accelerate a car from 0 to 35 kilometers an hour is more than, equal to, or less than the amount required accelerating from 35 to 70. So in this question, we need to remember that work equals the change in kinetic energy. That's on the formula sheet over here. And we know that kinetic energy is half m v squared. And then to calculate the change in kinetic energy, it's going to be half m vf minus vi all squared. So let's see if this will change the work at all. If I want to accelerate it from 35 to 70, it will be 70 squared minus 35 squared. And to accelerate it from 0 to 35, it's 35 squared minus 0 squared. And 70 squared minus 35 squared is greater than 35 squared. So that means the work required is also going to be greater. So this is option C. 19. The head of a hammer with a mass of 1.7 kilograms is moving at 4.2 meters per second, and it strikes a nail and bounces back with the same speed after a collision lasting 0.085 seconds. What's the magnitude of the average force that they exert on each other? So first I'm going to figure out what the momentums are. So P1 is going to be the momentum of the hammer, which is 1.7. So this is mass times velocity. So it's 1.7 times 4.2. And this is 7.14. And we know that the second momentum, P2, is going to be 1.7. So this is after the collision, minus 4.2. Because it bounces back with the same speed. So it's the same magnitude, but opposite in direction. So we put the negative in front. So this is negative 7.14. So going back to the formula sheet, we know that momentum equals, the change in momentum equals net force over time. So delta P equals F net delta T. Delta P is final minus initial. F net, and then T is 0.085, and the net force is 168 newtons. And honestly, I just disregarded the sign here because all our values here are positive anyways. So it's option D. Next, a rubber duck is on a frictionless hill at a height of 20, angle of 30. It slides down the hill with initial velocity 8.5 and collides with baseball or beach ball. What's the final speed after they stick together? So here you need to use energy again. So at the very top, so this is the top of the ramp, our duck has gravitational potential energy, but also some kinetic energy. So this is mgh plus half mv squared. This is 7 times 9.8. Our height is 20 meters. And the initial velocity is 8.5 meters per second. So this should give you 1,624.875 joules. Now at the bottom, because energy is conserved, at the bottom I only have kinetic energy, and this is equal to the same amount of energy that I had at the top. So this equals half mv squared. And now I need to solve for v to get the speed at the bottom of the ramp. So v is 21.55 meters per second. So because it's a frictionless hill and we don't lose any momentum, P1 equals P2. So what is P1? It's going to be the speed, it's going to be the mass of the duck times the speed at the bottom of the ramp. So it's m, or 7 times 21.55 equals, after they stick together, I need to add up both of the masses. So 7 plus 5.5 V, which is what I'm trying to find. And then this is 12 meters per second. A 5 kilogram object is moving at 5 meters per second south. It strikes another 5 kilogram object moving east at 4 meters per second. After they stick together, what is the speed of the combined object? So I have something moving south and something moving east. And what you notice here is this is a right angle triangle. So I'm going to use something similar to Pythagorean theorem to solve this. So when they're stuck together, that's 10 kilograms. And we want to find the speed after they stick together. So that is this part, the hypotenuse of the right angle triangle. And then on this side, I must square root. And then I'll have 5 times 5 squared plus mass times velocity again. So 5 times 4 squared. So this is 10V equals 32. V equals 3.2 meters per second. So basically just a Pythagorean theorem problem. 22. A 150 centimeter long string fixed at both ends oscillates and its n equals 3 node with a frequency of 100 hertz and a max amplitude of 5 millimeters. The tension is 80 newtons. What is the mass of the spring? So I see that the string is fixed at both ends, so I need to use this equation. So remember that this is fixed at both ends or open at both ends. This is one fixed, one open. So I know frequency is 100, n is 3. I'm trying to find C because I see that I have tension. The only formula that includes tension in it is this one here. C equals root T over the linear density. So I know I need to find the components here in order to find the mass, which is coming from the linear density, right? So I know I need to find C because I know T already. So this is 2, the length is 1.5 meters. So C is 100. So 100 equals root 80 over mu. Square both sides. And you'll get mu is 8 times 10 to the negative 3 kilograms per meters. And I have 1.5 meters of string, so I can simply multiply it by 1.5 and I'll get 0.012 kilograms or 12 grams. A thin film of oil has an index of refraction of 1.47. It's placed on a sheet of ice. What is the smallest oil film thickness for which light of 602 terahertz reaches your eye due to constructive interference? So with these types of questions, I find it helpful to draw a diagram first. So this is the oil film, and I have ice underneath. So we're shining light with a frequency onto it, and it's always going to look like this. So some of it is reflected first, and then some reaches the bottom and then is reflected again. So let's just say it's at a trough here. It doesn't really matter where you start with. Because oil has a higher end than air, this is going to flip around. Then the next we'll go through, because ice is 1.3 and oil is 1.47, we know that if it hits something with a smaller index of refraction, it's not going to be inverted because it's treated as a free boundary, right? So that's what our diagram looks like. So it says we want constructive interference. So we want the part of the wave to match up, but right now I have a crest and a trough. So I need to use the switch equation, which is 2d equals m plus half times wavelength over n of the film. And d is what I'm trying to find. So first, I know m and I know the n of the film. I need to find the wavelength. We're given the frequency and we know the speed of light, so I can find the wavelength right now. So c equals frequency times wavelength. So the wavelength is 3 times 10 to the 8 divided by 602 times 10 to the 12 hertz, which is 4.98 times 10 to the negative 7. So now I can plug my wavelength into the equation. So 2d equals, m is just going to be 1 half 4.98 times 10 to the negative 7 over n of the film, which is an oil film, so 1.47. Now all you do is solve for d, so 5.88d is 4.98 times 10 to the negative 7. D will be 8.47 times 10 to the negative 8 meters, which is 84.7 nanometers, and it's closest to A. Next, two strings are adjusted to vibrate at exactly 300 hertz. When the tension in one string is decreased slightly, we hear 5 beats per second. What's the new frequency of the string? So we know that frequency of the beat is F2 minus F1, and the F beat is 5. So we know that the new frequency either has to be 305 or 295, so it has to be 3 hertz lower or higher than the next one. So is it lower or higher? Well, we know these equations. So it says the tension of one is decreased slightly. So if we decrease the tension, we also decrease the speed. And if we decrease the speed, we decrease the frequency as well. Okay, so that means the frequency is decreased and it has to be 295 hertz. For Young's double slit experiment, when laser light with a wavelength of lambda 1 passes through the slits, we have the second fringe appears at the same location as the fourth fringe. What is the ratio of lambda 1 to lambda 2? So for the double slit experiment, this is the formula that we need to use. And it says that it appears at the same location. So I'm going to keep this constant. This is not changing, but we are changing m. So for lambda 1, it's 2 lambda 1, and we have 4 lambda 2. And we know that these two are equal to each other because it's at the same location. So if 2 lambda 1 equals 4 lambda 2, we rearrange for lambda 1 over lambda 2, and this will be 2. So this is option D. Okay, you shine light into crown glass with n of 1.54 and it propagates into glycerol. Find the critical angle that the light enters to make it totally internally reflected. So we are going to use this formula. So the critical angle equals inverse sine of n2 over n1. This is not on your formula sheet, so if you haven't already, add this formula to your cheat sheet because you're going to need it and it's very helpful. So N1 is also greater than N2. So all I need to do is find the critical angle. So arc sine is, so smaller one over bigger one, so 1.4729 over 1.54. And this should give you 73 degrees. Next, three separate strings have the same linear mass density. String 1 has length L, tension T, string 2, 2L, 2T, and string 3, 3L and 3T. The pulses start at the end. If they all start at the same time, what is the order that they reach the other end? So I'm going to use this formula once again because it includes tension. So string 1 has tension of 1. String 2, so I'll call this C1. C2 is 2T over mu, and C3 is 3T over mu. So let's find out how much this changes C. So this is just root 2 times T over mu, right? And then this is C. So I just have to calculate root 2, which is around 1.4, and root 3 is 1.73 of C1. So that means that string 2 is 1.4 times faster than the speed of C1, and C3 is 1.73 times faster than the speed of C1. But it is 2 times longer and 3 times longer. So it is longer than it is faster. So because it's longer than it is faster, it is going to reach the end after C1. Okay, so that means that the first string will reach first, then the second, then the third, because the speed at which they increase in is smaller than the proportion of the length of the string that's being increased. Hopefully that makes sense. So 28, an organ pipe closed at one end and open on the other has a length of 2.5 meters, vibrate with a frequency of 170 hertz. What harmonic, so what is N? If the speed of sound is 340 meters per second, I'm going to write out what we know. So length is 2.5 meters, F is 170 hertz, C is 340 meters per second. So because it is closed at one end and open on the other, I need to use this equation. So Fn equals Nc over 4L. Frequency is 170. We want to find N. C is 340. 4 times 2.5. And solving for N, you'll get N equals 5. 29. A beam of light passes from water into air. Which statement is necessarily true? So we're being asked if the frequency, like how the frequency or the wavelength changes. So as we know, Fn equals F. Frequency never changes based on the medium. It only is affected by the source. So frequency is always unchanged. So it has to be either A or B, right? And what happens when what happens with the wavelength? Well, C equals frequency times lambda. When light passes from water into air, air is a thinner medium, so light is going to have a faster speed in air than water. So C is going to increase. And if C increases and frequency is unchanged, lambda has to increase. So it's option A. Last question, which of the following functions represents a traveling wave? So a traveling wave is these ones over here. So the easiest way to look at this is see if x and t are of the same degree, and you can isolate for x. So what I mean is, so in option A, I have x squared and then pi times t. These are not of the same degree, so it's not a traveling wave. Same goes for here. This is square root of x and t. Here I have sine x minus sine t, so I can't write it in the form of x plus or minus t because there's no way I can fuse these two together. And lastly, this one makes no sense. Why are they in the exponent? So the correct answer is B, because I can factor out the 3 and make it like, or I can do cos 3x minus 2t squared, which matches the format over here. So the answer is B. So that's the end of the exam questions. Hopefully this was helpful, and good luck to everybody today.